Right, so this is part 2 of make your own PCB 3D print it. This is really how not to do things. You saw in part 1 that we went completely off the rails and we produced our production prototype. Here it is. And I've been using this, sort of looking back in time at the moment, but we had something like 7 hours of footage, which I condensed down to like 1 hour, and I chopped out a heck of a lot of stuff. So if there's something in there that you kind of missed out on, or that I glossed over that you wanted more detail on, by all means leave a comment and I'll sort something out and see what I can do for you. But the files for this are all in the Git repository, which I'll leave a link to down below. Now, there's a disclaimer here. If you can't follow along at your own risk, click this off, because everything you do and say, I do and say, it's my attempt to give back to YouTube. And what we're trying to do here is generate this PCB holder. It's not made for holding metal parts. It's not made for anything. It's just made to clamp your PCB in while you work on it. So, sit back, strap in, and we're going to get to part 2 of the design, which is going to be the production candidate. Now, our production candidate was a failure. That's what it ended up being at the moment, and there's only one little bit of hardware in there left that as you can see, it's literally a failure. That's too high in the air. These holes don't work correctly. We forgot the mounting holes in the base. So as a production candidate, that failed. And I need to pull it apart, which I can now do. I can recover that hardware and I can put it into the actual production candidate, which is this, which as you can see, it now has this on it. Now, I want to go through talking about this. One of the big failures I had was actually with this jaw, and what happened was that you saw in the Pt2 software that it had no attaching piece to lock it in place in the print, and what happened was it actually broke away from the bed, and we lost the jaw in the first attempt to print this out. And you can see that this jaw is actually a little bit thicker than those jaws, and that's because the jaw is actually now the same thickness as these are, and we've actually got the correct dimensions in there. Now, we fiddled around with the design, we fiddled around with the process, and we fiddled around with how we presented the project. So all of those things changed in part 2. And because it was ad hoc, we've got probably another 15 hours of footage, which I'm now condensing into around about an hour and just over an hour of footage. And what we're going to do is we're going to finish this video at this point where we've got this. Now, if you don't want to watch all the video, you just want to print yourself out a PCB holder and buy the hardware, that is a 13mm long threaded bolt, and as you can see, the top bit's got no thread on it, and that came out of a thing that you use to clamp bits of wire together. So it had a hook on it, and you wind that up and the wire tightens. So that's what it was for. And I chopped the hook off the end of it and ground that down a bit, and now I've got this, which as you can see moves that jaw along quite nicely. And it fits it's an M6, so by chance it was an M6, and it's got the nut in the middle there. So that nut is actually in the middle there, and it does a better job than just plastic for clamping the head of your screw in. So I'm going to get this hardware back out of this failed design and pull this apart and set that up in there and put the bits of wire back where they belong, and we're going to come back and see that all happening. Recording again. I wanted to take you through this. I did this on the 17th of June, which is today. I stayed up last night sort of doing this. And just taking you through my description here, is building a soldering arm. Now, it has a 3D print support bracket underneath it. As you can see, there's just a little bit of material here to support these bits for 3D printing. But if you don't want to, if you want to talk about things and review just comment out the support and render the job, and that's what they look like when they're trimmed up and ready for production. So these are just simple things. Once I built this arm first, this is arm 1, and as you can see, it's got a tapered bizzo that goes into the handy, the PCB holder, and that forms an upright, and there's a rebate there for this neck, right? So you can put it up or you can put it down through this neck, and then you can rotate it around with this will rotate in the holder. So then this is arm 2, so this fits into this arm. Just let me get this out. So this little sphere is gauged to push into here. These are only thin, but once it's in, it doesn't come out. And I'm thinking about whether I need a lock collar to come up over this and just lock it so you can just lock it off. I'm thinking about that. I'm not going to bother about it just for the moment. I'm going to print one out and see just how good these jaws will hold the sphere, because it's calibrated to the sphere. So this neck goes into this, and then you've got full rotation up and down and through 90 degrees. So you've got X and Y rotation and Z rotation here through 90 degrees, right down to where so that should reach back down. But then I thought, well, why not do a third arm? And this arm has that rebate in the end, that the jaw thingo, this little thingo here, there's bizzo wizzo. So that's going to push into this bit over here. So that bit there that you can see on the screen pushes into this bit here and gets clamped in. So the idea is you can still rotate it around. So you can rotate your part, you can rotate the whole arm, you can rotate this, that, the other thing, and you've got 3 points of rotation, so you should be able to get it at any angle you need to solder onto your job. And that's as clever as I got, other than I thought, well, that's not going to lend itself out to being 3D printed. It needs a support structure, so I just quickly did a little support structure for it, and when you render that up, it gives it that support so that it'll go to the printer, and the printer has some hope of actually printing that out. Now I'm looking at the printer at the moment, and it's not doing too bad a job of dealing with that. That looks like it's going all right. So yeah, I think we're in with a shot. It's nowhere near as neat as this thing, right? Nowhere near as neat as this, but you know, it's just me prototyping. I might make these if these PCB holders are something that people want, and I can sell them through the thing. They're completely recycled, right? Other than the nuts and bolts. No, the nuts and bolts, they can be made from recycled steel, so there's no reason I can't, like my nut and bolt guy, I always ask him, you know, like, can I use a manufacturer that's running with recycled metal? And he says most of this stuff is recycled car, you know, like recycled car engines and exhaust pipes, and you know, like the stainless and that, it's mostly recycled. It's cheaper to get it recycled, melt it down, and put it back through the molds than it is to, you know, to get new steel. So most of the nuts and bolts and that you buy are actually recycled metal. And I didn't know that. And I just said to him, well, like, that makes me feel a lot better. I can use them. So I'm using them. I use my nuts and bolts and washers and screws and God knows what else I use there. You know, all the metals, the gal coatings and all that stuff, the zinc, it's all recovered stuff. It's recovered, and they still mine zinc and they still mine it, but they're not consuming it in the small bits as much as they were. Not even close. Tools insist on new metal, but like your tools, but there's no reason that they can't be made from recycled metal. There's no reason at all. So I got to get the hardware still. You get the idea with this. You can see where I'm going with it. I'm going to 3D print this out. You can hear the printer going. It's how far away is that? 36 minutes and 6 seconds away from being finished. And you can see here where it's up to. So, hey YouTubers, 35-cent coffee. Yeah, it's complete contraband, guys. Complete contraband, and I'm loving it. No one here to tell me I can't, but I'm going to pay for it. I've got to double my walk up so I can have this. I've got to double my walk. So I do 2 kilometres every day. I've been told I've got to drop 10 kilos before my operation. So I've got to drop basically 2 kilos a week over the next 5 weeks, and I'll be good to go. So to do that, I'm walking 2 kilometres a day, and that's up to the shops and back. And on the way back, I carry the groceries, and that's, you know, that puts extra strain. And I'll drop 500 grams on each of those walks. And when I rehydrate, I put back on 100, but then I'll do an extra bibs and bobs and what have you, plus a bit from the diet, and I'll drop the extra 100 grams. So I've got to lose around half a kilogram. Yeah. I've got 5 weeks, so I've got to lose 2 kilograms a week. So I've got to basically lose around half a kilogram, you know, over a day and a bit. And I'm actually doing that, and you know, you can't go past a 35-cent cup of coffee. That's really, like, it's good. It's good coffee, and so that's why I have my 30. It's my treat to me. But I don't have them that frequently. But I've had one every day for the last 3 days because I've been feeling a bit crap about myself. Now that said, I want to welcome you back to the channel again. Excuse me. It's that last little bit of coffee. I scratched and scrounged, and I've come up with a bit of hardware to finish this prototype PCB holder. Now, there's a couple of things about this. These holes are too big for the guide holes for the coat hanger wire. The coat hanger wire is just under 3mm, and I've made those holes 3mm. So they actually slide backwards and forwards, and I've had to put some bits of off-cut PLC in the hole to jam it in there to wedge it. But as you can see, it's holding the PCB just fine, and it's doing the job it was designed to do. Now it's lefty-loosey, righty-tighty, right? But only if you're on this side of the jaw. If you're on the side I've got the board in, it's righty-loosey, right, and lefty-tighty. So righty's loose and lefty's tight. So if I want to tighten it up, I've got to go that way on that side. So what I'm going to do is put an arrow on the jaw to tell me which way to go to tighten. Right, so the arrow will indicate which way. If you're on that side, the arrow will indicate that you've got to go that way to tighten. So if I want to loosen this off, I've got to go that way. Got to go against the righty-tighty rule. It's righty-loosey on this one. So I'm actually gonna add that to the design. I'm going to revise this a little bit. I'm going to thicken up this outer wall because that's now, I mean, it's not the best resolution for printing. It was just my prototype, but it gave me the clues that I needed to make that a better application, a better fit. Yeah, so let's get on with that. I think what we can do is we can have four splits in it instead of 6 for those slits. So I'm going to change that to 4 from 6. So there's less slits and there's more. I mean, the slits are good enough, you know, like they do the job just good enough. And I think that the rebate's upside down. It needs to be the opposite way up. So I think those two things will see us right. It'll allow us to clamp in that ball and give it enough freedom of movement if we invert the rebate, the rebate in the top of the arms. So there's a couple of changes to be made to the design, and I'm going to swap cameras. So we're a couple of days down the road. I think I made a recording yesterday showing you guys printing out of the accessory. Today is going to be about finalising the design and 3D printing the final PCB holder. So let's get that, the final components. Now, this was just stuff I had lying around, right? So this is an old, what do they call them? They're a hook, a tensioner hook for, you put a cable there and you put a bizzo between this and another one of these on the other side, and there's a bizzo and it tensions it up to pull it tight. And it's for pulling wire tight. That's what it's for wire or steel cable or wire. And it can be used, in different applications. This is only gal, so it's not like it's only cheap gelled stuff. And that's a bit of old coat hanger that I found in the cupboard. I sacrificed a coat hanger to give myself the coat hanger wire, but it's old and rusty, and it's not the best. But even that's got its uses, and when I get the proper hardware, I'll replace the hardware in this with the proper hardware, and we'll have something that I can give to one of my mates, and he'll appreciate it because it was handmade by me, and he'll love it, and what we'll have to do is put the arrows on there so he knows. In fact, I might just draw them on now while I remember. So it's lefty-tighty on that side. So the idea is you grab a marker and you put an arrow in the direction of tighten. And there it goes. So for this one, the arrow is going to go that way. So now there's no ambiguity about which way you go to tighten. And everyone's happy. So if I want to add more tension to that, I go that way on that side, and if I want to add more tension on this side, I go that way. Which is kind of nice, isn't it? I mean, that is kind of nice. And I've had to wedge up these collars as well, so they've got a couple of wedges in them. The bottom one hasn't. It's proper, but this top one's had to be wedged up because of this hardware. It tapers off at the top. There's nothing I can do about that. So I might put a notch in it so that it's easy to get wedge a bit of put a key, wedge a little bit of plastic in there as a keyway to stop it from falling off. So let's swap cameras and add those changes. Okay, so we did all the 3D printing. It's Saturday morning. Beautiful, beautiful day out there. I need to get myself organised a little bit. I've got so much running. I just wanted to show you, this was a 10-hour print on the 3D printer because I asked for a better resolution, right? So that's it. There it is. Now, if I've got one criticism, is that these little guide holes here on the side, they're just a little bit undersized. But I'm not going to change that. If you want to make them a bit bigger, like 0.2 of a mil bigger might be a bit better. Because as you can see, the wire goes in, but it's such a tight fit that you have to really tap it in all the way through. Now, I don't mind that. I think that's going to be okay. So I'm not going to fiddle with it. But if you guys want to fiddle with it, please, by all means, do so. You can change any part of this design because I'm releasing all this code, right? So if you want to have a crack at it, have a crack at the code yourself. I mean, there's the design. The measurements are all in the library file, and I've shown you how to include the library file, and I think you should look at my code but have a crack at writing it yourself so you understand it. There's the arm, right? So we've changed the foot. It's now a ball, and it fits in that ball fits in these holes for the accessories, right? So I turned it into a ball because it just gives you more degrees of movement, right? Instead of just a straight, you've just got that little extra bit of a degree of movement. And you can see that some of these holes need to be reamed out a little bit. But it's a tight fit, and that was the idea, so that you could move the arm wherever you wanted it on the job, around this way, around that way. And they fall out. You just clip them in where you want them, put them there, and clip it in and lock it off where you want it. So it's right there, and it's holding the. If it's down here somewhere, then it's there. Now this leg here is probably a bit long. It probably needs to be a lot shorter. So in the next iteration of this, I'm going to put a short leg in as well. And I'm going to make that mod. I'm going to shorten one of these up. Sorry, this final leg, I'm shortening it right up so that instead of this being up there somewhere, it'll be like that, so that you can get it easily to the board, from the third one. Because the length of, I didn't account for the length of this jaw. That's what I didn't account for. Or you could put in a fourth jaw. You could have it out there somewhere, and then you could come right in underneath. You could have it in any place you wanted. You could have any kind of accessory you want in those holes. Anything that you want. And this hole here, it's a little bit too big. I'm going to take like 0.2 of a mil off of it. I'm going to shave it so that it's just a bit tighter. And I think those rebates, like having 5 of them in there, it's too many. I think you can have 3, and that'll work just fine. You could have 3 rebates. Or even 1 rebate. You don't need as many as I've put in there. So I'm going to change this arm again. And that'll probably end up just being spare parts for, if I need to grab an extra one of those. Like if I've got a tool job, I can put another arm in there, right? So it can get up to a nice big tool job that's in the vise. and get to where I want it. So this has to be shortened right up. This only needs to be about that long. So it needs to be about half the existing length. So this little thing here is just going to be, I'm going to chop that in half, that length, right? So it's going to be half the length because I didn't account for this being so long, this bloody thing here, the clip. Righto, so we're going to make those mods again. We should have worked that out from the prototype, but we didn't for whatever reason, not thinking. But for something that's made at home, that's going to serve me quite well. And what I'm going to do is I'm going to fix up this bright where I'm going to chop that hook off, right, and put a handle on that. And I'm just going to give that to that prototype there, to one of my mates who'll appreciate it because he works with PCBs a lot. And so, bit of bonus footage. Found a nut that goes, it's a 12mm M6. So we need a 12mm, whatever that is, rebaited in. And yeah, that's working just fine. Ugh, it's gone. It's going to take some work to make it fit exactly where you need it. And by the time you've wound it on a few times, and back a few times, and up a few times, and back a few times, it'll be where it needs to be. And I think it's important that we get some grease in there. Pack in a bit of grease to lubricate that up so it will have zero problems going forwards and backwards. So that's going good in that direction. It's going good in that direction. I took a file to the end of that and cleaned it up a bit. Not much. It's a bloody crappy file, let me tell you. It's a really cheap one. I've got to replace my files anyway. That one was a cheapy bin job, and it has never been any good. It doesn't take much material. If anything, it takes material off the file. That's how cheap and crappy it is. But that nut that's in there, that's doing a proper job. And that's what we want it to do. We need it to do a proper job. I still can't turn that by hand though. I can turn it easily with the tool. I think I'll put a bit of grease on that and a bit of lubrication on it. And that way that'll do what it needs to do. But the good news is that's making that go a beaut, an absolute treat. So that's the way you need it to turn. And you can turn it with your fingers without needing the tools. But I'll get that sorted, and yeah, that'll work. We'll get that going forwards and backwards. I think a bit of lubrication on there will help it immensely. I'll do that. And I'm going to go back to the design. So we need to, I've had to ream that out. I've done that rough and ready with the soldering iron. I've just melted it out with the soldering. But we need that to be 12mm minimum. And I need to know what that is point to point. So we'll get the calipers on the point to point for that nut. Got another one here. I'll get the calipers out and put it on there. On 0. Alright, here we go. Let's just check the 12mm. There it is, that's 12mm. And we're going point to point. So we're at nearly 14. .93 point to point it is. So it's 13mm. So we need to change that rebate up to 13mm. So that can be done. That's easy. We just go to our properties file and change it. So I'll make those changes. Okay, so I'll insert this little bit before the end so that you see what's going on. But that's what I used. I used a bit of a scroungy old manky bolt that I had lying around in the toolbox. Right, so here's production candidate and effort number 2 with all the hardware on it. And we've got a couple of problems.
First problem we got, knob's not tight enough for this particular shaft, and that's because I kind of mungled the shaft when I cut it. Second problem we got, these are too high. They got to be towards the bottom where the original prototype was. So because they're too high, you can get a board in there, but they're whacking against these keepers. Right, so what we need to do is drop that back down towards the bottom. But as a production candidate, it's told us a few things. For example, these work, right? So this is still useful because you could put extended jaws in those, and the jaws could come up here, and then they can be different shapes and sizes and whatnot. So you can just have pegs in there and, you know, just extendable jaws on it. And I think that's a good idea. So we're going to keep the holes. I've already made one more adjustment, and that is that this hole in here is too tight. It's only a guide hole, and what it's doing is it's grabbing. Now I'm just going to pull that off for a minute, and I'm going to use my little winder that I know works, right? And what we can do there is we can jam a nut onto that to overcome the problem. And we can use lubrication to a degree. And by the time you've wound that around a few times, that'll be just fine. But you can see there, the guide's starting to stick out. And that's because this hole in here is too tight. It doesn't need to be that tight. And you can see it's pushing that guide out just a bit. And I'll put some lubrication on that and run that up and down the track a few times. And this will still be useful. I won't use it. I'm going to make yet another one with the final production candidate. But by the time I've done that a few times, that'll loosen up. Plus, bolt void's in there, and we want a key way. And we're just going to add this keyway. And there, you know, that's going to be massive now. It's just, actually, it's done almost exactly what I want. Holy crap, can you get any luckier than that? That's exactly what I wanted. So we can wedge a little bit of plastic in this hole and give ourselves a good snug fit, and it won't move. That is absolutely exactly what I wanted. And then on this one, it'll be hidden up. Let's get rid of the 3D printing so you can see. I'm just going to chuck this into comment mode. I knew that'd be quick. I didn't realize I'd get that lucky. But yeah, there it is there. There's a little keyway even in the bottom one, so that when we throw it in there, we can lock it off with that keyway. And that'll stop it from moving on, you know, it'll wedge it up against the bolt, and life will be bloody good. I'm happy with that. I don't know why I'm happy with that, but I am. Because that's basically exactly what I wanted it to do. Well, how lucky was that? We got it in one hit. Good enough. Default is going to be good enough for this bed. I don't want it overly, like it's a 10-hour print if it goes overly overtime. Now this thinks it's going to take around 4 hours to print. And is that resolution going to be good? I think that's going to be okay for us. Now with this one, when it's finished, I'm going to be putting the alfoil over it to protect it from solder spills. So I'll get the bright wear and all the bibs and bobs and fittings that I need from the bolt shop. I think they're open tomorrow morning, so I'll probably be able to duck up there in the morning and grab them. being a Saturday, I'm not sure, but if they're not open, I'll have to leave it till Monday. But I'll go for a ride on Zoomy. I'll take him for a bit of a ride. The arrows are rendered out. You can see them there. Yeah, I think I'm happy with that. I think I'm okay with that. That's looking all right for a print. So that's all sliced up. Let's just go ahead and print that out. G'day, welcome back to the channel. I need you to just forgive the way I look. We've been in lockdown for a bit and I've been tracking a bit tough at the moment, so I'm damn the torpedoes. Let's just move forwards. I'm going to skip forward in time. This is a prototype of what we're trying to build, which is a PCB board holder. This prototype functions and works, and I'm physically using it, as you can see. I've actually used it to do a bit of soldering work and cut some stuff, and works just fine. I went from that to this, which was a failure. It was a failure because this bar is too high, and it still works, as you can see, but as you can see, we've had some feature creep. We've now got a handy helper arm which isn't really doing what it needs to do, and the bright wear that's in that's going to get recovered, and the hardware will get recovered, and we're going to go to this, which is the final candidate, and this doesn't really work for me either. The holes are just a tad tight. PCB holders in there. The idea is the handy helper arms in there. It works. It's got modifications in that it's got accessory holes and it's got some mounting holes in it, and this will be the final design. I'm not going to muck with this anymore. You're more than welcome to muck, but this is our final design. In getting to this, we went from this to this to this, and as you can see, I haven't bothered assembling it. I've got to take the bright wear out, the hardware out of this one, and this was a failure. It's got to get recycled, but I'll take the hardware out of that, put it in the new one, and that'll be it. I'm not going to muck with it anymore. Well, that took 10 hours to print out for me to decide that I don't want it. And then the final version, this one here, which is you can kind of see that it's, can't get this out. Right, you can kind of see the cross hatchings are 8mm apart, and it works just fine. I'm much happier with this as a final design than that candidate over there, my production candidate. This is more my production candidate. It's got mounting holes in it that I never thought of in my prototype, and that's the one thing I'll probably end up drilling them into the prototype, because I'm going to mount this to an arm that I can bring into the job and push out of my road. So this is just going to be something that I'll be able to put on the end of an old lamp or something that I've got knocking around in the scrap. I just want the arm bit of it where I see how that's got a, that light there's got a little stand and an arm on it, and you could put that, you could get rid of the light bit and put this on the end of it, and then that can come into your job, and when you finish with it you can push it up out of your road and it goes away. And that's the sort of thing I want. And I'll have that, maybe I'll have that with the magnifying arm. I'll build a bracket off to the side of the magnifier and have, so I can swing that down under the magnifying glass and do my work, under the magnifier. That's a good idea. And so I can have a bracket for that,
where I can just, I can swing it up out of my road, or I can swing it down underneath the magnifying glass, and it can sit there until I need it. Right, so what did we end up with? Well, here it is in all its glory. We've got a handy arm which fits into the accessory hole. Pick any hole you like. You have as many arms as you like. If you've got more alligator clips, you've got more alligator clips. There's our final design. You can wedge those in. Some of those holes are a little bit tight. I might have to look at that. Yeah, there's some crap in some of the holes. But you get the idea. Now that mechanism's a bit stiff. That'll free up with time. You got a little electric screwdriver. You can shove it in the end. I've got a flat battery. But you get the idea. So you get an electric one of these, you just need to shove your electric screwdriver. No, that's struggling. Okay. Oh, it's struggling. The mechanism is pretty tight. I've put some lubrication on there. I've lost my grease pot. I've just put a bit of oil on them. By the time you do that a few times, that'll start to free up. But it does work. So there you go. We've got our PCB holder with our handy helper arms. I'm going to put a link to the Git down below. And that's the final result, which I'm using. Now, one of the things I did was I overwrote the values for this prototype. And this prototype, it actually works beautifully. So if you want an electric one, this needs lubricating. It definitely needs lubricating, but you understand what I'm saying. A bit of grease on that, you won't even hear it squeaking. Yeah. Okay, so you get the idea. So that one doesn't have the little arms in it, but it's still useful, and I'm going to use it. I might give that to my mate. I don't know. I think it's very useful. And my intention with this, because I put the mounting holes in the bottom, so you can see there's 4 screw holes, I can mount this to an arm. So I can be working, bring this in on the end of the arm, and then move it out of my road, and it can just sit up there until I need it. I can bring it in, I can do my work, and then I can send it back on its way, and it can still sit up there, and I can use it as a handy helper in isolation, or in isolation. So I could chuck that, for example, into that. See what I'm saying? And I can keep adding these things as I need them. I can put a whole bunch of them out, and I can just put them wherever I need them. So that's become something of a win, and that's a very useful project. So at that point, I'm going to sign this off. That's it for this project. Again, the repository's down below in the comments.
you're more than welcome to just grab the STLs and print them out like as you need them. You can just print them out and just use them. Make as many as you like. You do need that bolt. I looked at making that from plastic, and I gave up on it. I started to play with it. I think there's some code there where I started to play with it. You're more than welcome to expand on that bit of code. It's in there still. I didn't delete anything. So if you look through the code, you'll see it's not used. It's down the bottom somewhere where I started to make the shaft for the thread. And you can put a thread on it. And well, there's all sorts of things you could do. You could make that shaft out of plastic and then you could have the end shape, whatever you wanted, with some sort of a receptacle for your head, and you could change it to whatever you want to. There's enough there that you could go on with it. You could make anything out of that, and you can make jaws that slide into those accessory slots with odd shapes in them. So if you've got odd shaped boards or like round boards and whatnot, you've got the right gear there to hold the board proud while you're working on it. And I think if you need a little tip I was using, I don't know if I showed you guys this, a little tip. Let's grab a pair of tweezers. I've got all sorts of these tweezers. I've got all shapes and sizes. These are basically the ones I use more commonly than anything. But if you need to hold a micro component and that little jaw there doesn't do it for you, what you can do is you can put the tweezer into those jaws. Right? You can do these ones. Now, you may not have thought of that, all right? But I do that quite frequently, and that'll happily hold that wherever you need it to be on the job with the part or the component in it. Now, if you've got a bit of arthritis or something, you can do that. So if you've got arthritis and you're still wanting to work with fine stuff, you can do that. And sometimes that's easier than trying to hold that closed yourself. You can turn that into something where it's being held closed for you. Right, and this works quite well. And sometimes you've got to steady the soldering iron. You can put the soldering iron in a clamp situation with this, so you can get these handy helpers sitting in the job and come in with your soldering iron, right? So what's happening is you come into the job. Why can't you see this? Okay, so I've got the handy helper there, and let's just assume that's the soldering iron, right? If you're under a microscope and you're trying to do something and everything's moving, you can use that as a steady, and that'll steady your hand. That's just another use for what we've built, because that'll sit on the edge of your job, and you come in with it, and you can come in to an exact point, and then you can do what you need to do. Let me see if I can show you what I did. The old-fashioned way, right? Now let's do it the way I was doing it. So there's your PCB thing. It's a bit sharp, so I'll use me. But you see there, I'm using that as a steady, and if that's my job, I can come into the job with the soldering iron, steady myself, right? And I'm not shaking and moving around at all. And I can do my soldering, whatever I'm doing, and I'm just using that whole arm as a steady. Now there's another use for this thing, right? Now that's my whole hand is steadied. If you're doing fine work on something and you need to use it as a steady, you can. You can put multiple ones of those in, as many as you need, so that you've got a good resting point for your hand, and that'll happily come into your job and do whatever you need to do. Now I'm doing that on a hanky, but that can be a soldering iron, right? That can be a soldering iron. And if you need to further steady, you can use both hands to come in. Right, so now you've got two hands in the job with your steady. And that's not impeding me at all. I can work quite nicely around that. That's just another use for you. That's another reason why I put them. But some of you might not have thought of that idea of holding the tweezers in handy helper like that. And I've done that, done that for quite a while. And when my hands don't work the way I need them to, that's what I do. That's how I get around problems. You find a way and you move. You find a way and you move forwards. Right, coming back. I always set my computer on a hanky. What happens is this computer gets hot underneath, and that hanky just lifts all of the vents up off the desk that little bit more. So it gets a bit of circulation going on, and it doesn't get as hot, but this computer gets way too hot, and I know at some point I'm going to have to pull it apart, figure it out, but it works. And my feet were turning into a couple of icicles, so I went and grabbed a blanket I put over my feet and put them in a pair of slippers as well. 35-cent cup of coffee. Yum. It's hot. It's hot. I love it when my coffee's hot. Righto, so at that point I'm going to sign this off. I've shown you a couple of uses for the unit. If you can, support my company, nightglowmanufacturing.com. Look, there's a couple of other organisations worthy of your support. They're doing it tough like it because they're relying on your donations to keep operating. So I'll give them a plug. The openscad.org, right? They gave us the software, the CAD software for free. And so that they can continue to give a good product for free, I recommend you support them. Ice Cream Screen Recorder, there's a free version which will go for 5 minutes with limited features, but I've actually bought their product, and that's what I use for all the screen recording that you saw throughout the series and throughout all my videos. That's what I use. So by all means give them a look. Pt2 host, they put out free software and free versions of their product, and you can donate to them. So please, for 3D printing, Pt2 host, by all means give them a little bit of support as well. And last but not least, I want you folks to make good decisions and do good things. Like this video, share it by all means, subscribe to the channel if you so desire. I'd like your subscriptions. I'm not being commercial about anything. I'd just like more people to get the word out that this is useful information, and you picked up a couple of tips and tricks that I use. And yeah, good decisions, good things, and I'll see you at the next series of videos, which will be back onto Project Zooming. Thanks for watching.